I'm just going to demo solving a projectile motion problem. So in most introductory physics courses, a projectile motion problem is one where there's gravity, no air resistance or other forces. And therefore, the horizontal and vertical motions decouple. The horizontal motion is described by motion with constant speed, which means that the horizontal velocity is a constant at all times, and the horizontal position just increases linearly with time. The vertical motion is constant motion with constant acceleration, which means that the vertical velocity just changes linearly with time, and the vertical position follows a parabolic relationship with time. Here's a little sketch of a typical case. And to add to the complexity, often you have information which is geometric, where your initial velocity can be described either by its components, Vix and Viy, or by the magnitude of velocity and the angle. And somehow you have to integrate all of this information into solving a physical problem. I think the best way to illustrate this is by doing an example. I'm going to take an example from the text. I just grabbed somewhat randomly problem 32, which says that a rifle is aimed horizontally at a target 50 meters away. The bullet hits the target 2 centimeters below the aim point, then asks what is the bullet's flight time and what was the bullet's speed when it's left the barrel. The first thing I always do with a problem like this is I draw a little picture because, while it is a projectile motion problem, it doesn't really, this picture I have pre-drawn doesn't really fit it very well. All right. So the bullet is fired horizontally. So let me first draw some axes. Looks something like that. So it is fired initially horizontally. So the initial is horizontal, which means that the y component of the velocity here, y component of velocity, this is 0. And then they give us geometric information. So they tell us the distance that it flies, and they tell us the distance that it drops. And I guess the way I drew this with the arrows with double heads on it, that's often when you're measuring distances. That's a nice way to think about it. But if we want to get our signs right, it's probably best to actually have a direction on this. So delta x is xf minus xi. And so if I do my standard thing, that delta y is yf minus yi minus 2.0 centimeters. Okay, so the first question asks for a time. And a little pro tip, that in most projectile motion problems, if they ask you for a time, it's something involving the vertical motion you have to look at. It's not always, but it's a good place to start. So let's start by looking at the vertical motion equations and see if there's anything that we can use to try and get the time. Okay, so this first equation, that relates the velocities at different times. Well, we don't know any of that, so that can't be useful for this. This one relates the y position to the initial y velocity. Well, that's 0. And the acceleration. Well, hey, I think we know all of those things. So at the final time, this is just yf. And so I can bring this guy, this yi, over to the other side. So I can write y final minus y initial equals minus 1/2 g t squared. Oh, great. And our minus sign here and the minus sign there, they cancel. So now I will just solve this for time. So I multiply by 2 over g. And so I get 2 over g delta y, just multiply minus 2 over g. Minus 2 over g delta y is equal to t squared. And then I take the square root of both sides. And now I can just plug in numbers. And indeed, these signs cancel out. Now I look at the units. This meters cancels this meters. I get a 1 over seconds squared. That means the seconds are upstairs. When I take the square root, I get seconds. And then I just throw those numbers in my calculator. And what I find is 0.063887. That's what came out. And it's maybe more natural to write this in terms of milliseconds. So I bring the decimal point over 1, 2, 3 places to get milliseconds. And so this is 63.9 milliseconds. Is that reasonable? That's a really short time, but it is a bullet. And I think I remember hearing times like that when thinking about bullets. Okay, and I'll make another video with the second part.